now, as there's no intro to my stream. Usually what happens is I have this little thing happening on my stream before it actually starts. But since we are using this lovely product called StreamYard, I didn't set up an intro. So you get to jump right into our faces. So excellent. Welcome to, again, a very special stream. And today's topic is, I even have a banner, something like this. The title is vastly different than this, but this is in essence what we're going to try to do. And by we, I mean Goran here. So I'm just going to here be to support, ask questions, and maybe, try to understand it myself as well. So before I start, I would like to allow Goran to introduce himself. Kick it out, Goran.
Yeah, thanks, Darko. I'm working in Java and similar tech since 1995, and 1993 I made first website. So it's a long time, long run, and working in the same technology like Java it's extraordinary. It's very rare in tech industry to have something like that still works and works perfectly well, and most of big businesses use it as a core component of their systems. Yeah. And also I'm working a lot with databases, MySQL especially, and I'm a part of AWS Hero program, and share a lot of knowledge with my friends there, and people from AWS who are ready to share also, like you. Yeah, that's just in general, that's it.
The most important thing here, like unlike previous streams which you joined me in me trying to do something or kind of doing some very basic high-level topics on some technologies, Goran here is an actual specialist and an expert in a lot of things, besides just being an AWS data hero, which is a very, I guess, exciting thing. He's also very, very much experienced in Java. He's also experienced in running a company, so he understands what legacy software means or what line of business software is. And you may be aware that a lot of the line of business applications are actually written in languages such as Java and C# and C++ and whatnot. So, and then in this modern serverless world, we want to make sure that the code we have spent, since 1993 writing, right? So all of that institutional knowledge we have, we want to make sure to get that code to the cloud, to the modern serverless ways in the best way possible. So Goran is going to spend, I think, some time here today about talking about how can you make Java fast. Well, actually, sorry, that's a misnomer. Java is fast.
That's
exactly. I'm sorry.
That's a yellow card.
Okay. Nothing against Java. So Java is fast. Yeah. Starting Java on serverless can be slow. So, actually, using Java in serverless can be a bit sluggish. So, Goran has a few.
I would just say that there are some bad developers and good developers. If you make some mistakes, some error, some bug, and or you just completely make a completely wrong architecture for something, then you get some wrong results. So that's mostly the case. Yeah, let's start, and then we'll see what's good, what's bad. If I understand correctly, Darko, you are totally in Python, and
I like Python. I like the interpreted languages because that's how I started. I dabble in C++, but when I say dabble, I like C++, and that's about it. Never written anything possibly. But if you want to treat me as a developer-ish, treat me in Python. Let's call it that way. I started with PowerShell, so it's been a while. But Goran, yes, actually explain to us, show us how to be a better developer.
So if we want to make some great results in Java now, we need to, as it was always like that, we have to understand the platform that we're working with. So you cannot just make anything, and it can work. It cannot work anywhere. It's like people now trying to use Spring Boot or something in serverless, and then they get some wrong results. And we need to adjust things, and we need to think about the platforms. So let's start. Let's see what we have inside this program. And
while Goran is getting his screen share set up, while Goran is getting his screen share set up, I want to say hello to the chat. Hello, everybody. I see we have folks on Twitter, Twitch, and we have folks on YouTube. So hello. Yeah, welcome. Just a quick repeat. We are going to do some magic with Java and Lambda functions or serverless. So let's see what Goran has for us. I think Goran has enabled his screen share. Let me plop it in on screen right now. Oh, we even see a PowerPoint presentation. Well, that's a first.
Let me.
Feel free to blow it up. Yeah.
So I mean, you can not go anywhere without PowerPoint.
Yes, exactly.
So yeah, let's see what's on program today. This Twitch TV is a kind of a TV program. So let's see. First, we'll talk a bit about Java. Then we'll talk about the technology on which the infrastructure is based on, like Lambdas, serverless, Firecracker, stuff like that. We'll see how it works, and then we'll make a few demos, real code demos, and see how we get this Java working so fast. So I forgot the whole idea is to demonstrate some people that Java can run in absolutely the same speed like any other language, especially to Jan Chui and other guys who are always saying, "Oh, there's some problems. Java is maybe not for that."
Java is slow. Okay.
So
I want to see that. I want to see all of that, and I think even the folks here on stream want to see that. And I see that Marin says he cannot agree with you more. So, and Goran is actually going to build something, so it's going to be also some. We're going to see actual code.
These are some simple examples, but I try to organize them in a way that you will understand what's going on here. And also, I'm going to show you a great book. This is a remarkable book by a few great engineers. So I really want to show you this, and then we can discuss what's really important here, and if we change the way we're thinking about the Java and programming in Lambda, maybe we'll get some great results. So let's see. So Java is what's used for many things, but mostly now, if you see Java, it's some real business. So most of the big applications it's deployed in Java, and these applications, like in my case, I have the same code for 15 years, moving the same code from one platform to another, and now to Lambda. I mean, I told you a few days ago, I have a piece of code that is resizing images in Java that's surviving for 15 years because it's a great unit. You can use a simple piece of code that does that exact thing, business logic, and then you can put some interfaces to it, but it's still doing that same thing. Yeah. So
when it comes to Java versions, how? I mean, you wrote that 15 years ago. I'm not sure what Java version existed there.
Yeah, we always compiling it. You always kind of recompile it for new platform, edit. But the same code is there, and you could run some old code, but in general, you always put it into some context. But you can copy paste in general, so that's a great thing.
Okay.
Yeah. So in terms of deprecation and stuff like that, Java is just brilliant. The people who are gonna guide Java for years do that in a perfect way. So we don't have any really big issues with Java. Like if I remember correctly, all that problems with the Python 2 and Python 3 just because of Unicode and stuff like that. Yeah, we didn't have that problem in Java.
I can imagine. Well, I mean, did you have to change any code between Java versions if you compile them for different versions, or would the same code work?
Yeah, mostly. Yeah, I mean, mostly.
Okay. Because I know the big change from Python 2 to 3 was a mess. Yeah.
Like 2 or 3 versions, years, and stuff like that.
Okay.
So Java is now changing very quickly. So we get versions every 6 months. So it's even less. I don't know. So it's now version 14. It's 15 is coming, and it's going to be 16, and then the 17 is going to be the major release. So we're now in mostly there are 2 versions now running all around the world. It's Java 8 and Java 11.
Yeah.
The rest is like a minor percentage.
Okay.
So we're going to work with Java 11 today, but we hope soon we'll get some great benefits from new versions. I'll talk a little bit about that later. So why is Java so great? Because it's strongly typed. So if you have a bad developer, you're fine. I mean, there's not going to be so many mistakes that you can, the mistakes you can do with some languages that can be dynamically interpreted, so that that can make stuff fail in runtime. So in Java we try to detect so many things in compile time, and that's so great. And Java is fast. The problem with Java is that those people that made all these servers that run Java made us think that we should load everything dynamically later, and things in that way, things just get slower and slower. And also everything gets dynamic. So like that's a good thing from one perspective, because if something is dynamically connected to your system, like some kind of like, let's say you make some connections to one database, like a MySQL, and then one day you decide, oh, I'm going to change that whole MySQL stuff with Postgres stuff. In Java, it's actually very easy to do these changes with some of the mechanisms, like for managing ORM, like mapping objects and databases. But in reality, you don't really do that in runtime. You do that once in a while, and you prepare for that. You build it, you compile it, and stuff like that. You don't do that on server which is running. But in Java, everything is ready. Like everyone is going to do that in some dynamic manner, which is not the fact. And especially,
but if you compile, like, so here is a loaded question: are compiled programs faster than interpreted? Like,
of course.
I guess, yeah. Okay.
Of course.
I just want to make sure.
You can get the final binary on that particular platform, and that's it. Okay. You don't have to have that layer that goes. But the problem is that dynamic part, and we're going to talk about that more in the next few slides. So just one page with a lot of stuff from Java and what's going on. And let me explain where we are now and where we're going. So like 15 years ago, maybe or so, maybe more, all applications were just Java servers, and someone was connecting to Java server. And then we started building that I call that monolith here, but it's probably not the perfect name. And then some first application servers came up. And application server actually provides everything for the application, like a connection to the database, connection pool, and everything, metrics management and stuff like that. So you just put your application dynamically onto that server, and it will run it.
Yeah. Okay. Interesting.
You put a new version, it will reload it, and then run it. So we have a server which is always running,
right?
And you can deploy new versions to that. So that was a great thing, and you, as you can see, it's dynamic. You can load classes in the runtime,
right?
And then industry realized, oh, there's something great about this, but there are many companies going into different directions. I was using like something called ATG Dynamo, like 20 years ago, and that's a great product now owned by Oracle, but it had these options. You could switch some code, like a class, in the middle of it being run on the server. So you just switch it, and then you have some completely different functionality doing the same thing, like changing.
What benefits does that give us?
Well, let's say you have an order for something, you have a calculation, and then you say, okay, I'm going to change the way how we calculate it, add some discounts and stuff like that. So you just make one class and then just deploy it there, and it reloads. So you can just switch parts of it, and
so
then
even on compiled code, basically, right?
No, it's all interpreted.
It's all interpreted. Okay, got it.
Okay, because I see you asking questions about that. So there's Java virtual machine. It's like a virtual computer. It's everything runs on it, and has to go through Java virtual machine.
Okay,
so
yeah.
It's interpreted, but when we compile in Java, we get this machine language. So it's very close to something that should be run on that machine. So when industry realized that that's a good direction, they made a standard. It's not like in Node.js where you have only one node. It's just like having a lot of different manufacturers of these servers. So they organized a standard that worked very well for a few generations. But then things got really complicated because everyone was making it more complicated. And then a great company, Pivotal, made what was the name of that time? I don't know. I remember. I forgot. So they made Spring. Spring was a revolution in terms of Java with all this dynamic loading of everything and connecting. I'll tell you more about that later. Yeah. So it was real revolution. So it was such a revolution that even Oracle decided, okay, yeah, that was a mistake. So the pressure for the community, Java community, which is really strong, made so many changes, and actually Oracle decided, okay, you're gonna manage this whole specification without us. So now we are in the process of moving everything to something called Jakarta EE. That's a new specification, yeah. And also in the meantime, as the community was growing and companies were just not really happy with Oracle guidance, a new set of standards emerged. It's called microprofile. So you have many really great specifications, and whatever a company makes, like a Red Hat or someone else makes a server, it has to comply to these standards. So whenever you write some code, you know that it will run on any of these servers. That's a really important thing. You make a REST client or REST server, it will work. So whenever you compile it, deploy it, it's working. So that's a good thing. And so there are many great things inside of it, like open tracing. If you can see here, open tracing is like an X-ray, AWS X-ray. We have many things already built in there. If you don't want to deploy it in the cloud, you can have it with the microprofile. Anyway, so two things that we talked was like if we compile Java, we actually build some kind of a bytecode. It's called bytecode. It's then running on a virtual machine.
Right.
And the new thing that we're going to talk about today is ahead of time compilation. Okay. So we're actually preparing everything, and then we can make a native Linux.
Okay, so when you do ahead of time compilation, you're actually making a binary which is not running within the Java virtual machine; it's running natively on the OS.
Yeah.
Okay, that's very cool. That's very cool.
Yeah.
Okay.
So let's go to AWS Ground, which is more closer to you. So
Lambda functions. Okay.
So Lambda lifecycle. Okay. So for those who don't understand Lambdas, it's like one function in the cloud, and you can call that one function. Yeah. It does only that. That's it. Yeah. You don't have to understand how it's deployed, how it's working. You just put the function and you call the function, and you get the result. So that's the whole idea. But you still have to understand how it exactly works. So there are some servers there, and on these servers there are virtual machines. These are very light virtual machines which can run those small functions that you deploy very quickly.
Yeah.
But it's still a kind of a container. These containers are running on some kind of a Linux platform. So if you put the Linux binary there, it's gonna work, just like that. Okay. If you put Java bytecode there, it won't run. You have to run Java virtual machine on the container, and then you have to run Java bytecode on it. So there is an overhead there. So you have to make these overheads somehow smaller. Okay.
Right.
So let's see what's going on here. The one of the things that everyone is talking about with Lambdas for so many years is cold start. It's time that passes when you first call the function, and then when to the moment you actually start in working in that function,
Right.
So
Got it.
that time, if you for Java developers who are working with application servers, if someone says, oh, it's going to be like few seconds, like in Lambda,
Okay.
they will be so happy, because
Exactly.
for we are running servers like Glassfish, Payara, stuff like that. That everyone is happy if it starts in like 20-30 seconds. That's just the magic, But most of my applications that first that we had in production were starting for like 60 seconds or maybe 2 minutes, And if it's a smaller instance, like we sometimes buy on AWS,
Yeah.
it can take 5 minutes for them to start, because it's loading so many things that they don't really need. Some of my first applications.
That's a very fair point. So this is something we have to point out, especially for folks who do not do serverless here. A start time of 1 minute on your server, it's amazing, right? From nothing to running is amazing. A start time of 10 seconds on a Lambda function, maybe too much, right? I'm not sure if it's too much, but you have to think of the scale here, right? It's very important to understand the scale of things when moving to serverless. Your serverless applications, your Lambda functions, are being charged per millisecond. Yeah, millisecond executions. So the more
blocks. Yeah.
Sorry, half a
100 milliseconds blocks.
100 millisecond blocks. Yeah. So the more optimized your code can be, it's not just a matter of fact of like, hey, I have code that runs faster. You have code that runs cheaper. And that's very important, right? So, and I think Goran will try to explain this to me right now.
So let's talk about what's going on here. Like when we deploy the function, it's waiting for someone to call it. The first time someone calls the function, AWS has to download that code from some repository, put it into that machine, that hardware, start it. Okay. So we're starting a container. Right. And then in that container, there's something called Bootstrap. That function also has to start. Okay.
Got it. Yeah.
And then when we start it, then we actually have something which we can, in that Bootstrap is the part where we can actually start doing something. Okay. Mm-hmm, mm-hmm. So there's not too much document, not really too much documents about these 10 seconds.
Okay.
But there is these 10 seconds. So let me explain. So if you have some of the runtimes like Java or .NET or I don't know, Node or something, and if these runtimes are provided by AWS, you get 10 seconds for initialization of your code.
Okay.
With one full CPU. Even if you choose a Lambda, which is like a 128 megabytes, the smallest one, like a 1/8 part of CPU, you get one full CPU during that init time. Mm-hmm. And then you have 10 seconds to finish this initialization part. It's like a class constructor. Whatever code you put into class constructor, if you finish it in 10 seconds, you will have one full CPU for free to run it.
Right.
Then the code that comes after the constructor will be the code that you will actually execute every time, and then you will pay for that code. So if you take 10 seconds for initialization and 10 milliseconds for running the actual code, you will not pay for these 10 seconds. It's free.
Yeah, exactly. But also, there's a minimum price. I think it's 1 second. Is it 1 second the minimum price of
100 milliseconds?
100 milliseconds is the minimum. Okay. That's very cool. But so, and this only applies. Do these 10 seconds only apply to cold starts, or is it just to all of them?
Oh,
Lambda cold starts. Okay, got it.
Cold start. You have to finish your cold start in 10 seconds. If you don't finish your cold start in 10 seconds, I think that they will kill it and then they will run it again.
Right. Got it.
But with your with the CPU you said you want to use, but it will take as much time as it has to take, and you will pay for it. Okay.
Got it.
I realized in some calculations that if I put some my own runtime, and that that's something that I will need if I remove Java from Java virtual machine from the system.
Okay.
I pay for it.
Yeah.
Okay, it's kind of a faster, but if it's my own runtime, I'm paying for it. So it can be a bit of a problem in terms of paying. Okay, it's cheaper. It's cheaper, but it's actually faster, so it can be.
By the way, just to add a thing here, anybody on chat, feel free to ask any questions. Even though we're talking about this in a PowerPoint format, you're completely open to ask questions at any time, and we can actually pop up your questions on screen, which is cool. And also, hello Zoran, hi, thank you very much. Zoran is from Macedonia. Yeah, he has been often on my stream, so hello. I apologize, Goran. Continue.
Yeah. So we have cold starts, and that's something that runs once when you start the function for the first time. That's your Java constructor. And then we have some other function, some handler that will be invoked. So if there is another request, we will again invoke the same function. So we'll just pay for this invoke, and that's it. After some time, let's say 10 minutes, 1 hour, whatever time, it's up to AWS. Yeah. Whole container goes down if no one is calling it. If someone is calling it, then it's never gonna be killed, or maybe it will be after 10 hours or something. So, but there is something.
Yeah, that's how cold starts happen. So cold starts happen if you never ran your function, and if after a while you don't run it, right? So there is a way to keep them all up. I mean, the traditional way, at least when I started at AWS, the traditional way to keep a Lambda function warm was to execute it every X. Now, I don't know what's the time when the Lambda function goes cold. I don't know the number or the time here, but what happened is, like, I would have customers basically execute Lambda function every 10-15 minutes with a dummy call with nothing. It will literally do nothing. It will just no op, and but it will keep it warm. So that's one way. Or there's a provision capacity.
That crap.
It can be a bit more expensive. So I think everybody's advised.
I'm totally Let me tell you again what I told you so many times about this provision concurrency. So this is something for really bad developers. Some people who don't know how to write code, so their lambdas need to run for like 1 minute to start or something. So if you cannot optimize your code, just stop. Don't do development. Okay, so
it's throwing money at the problem. Yeah. So try to avoid it.
Yeah. So the provision concurrency is a solution. So that makes your containers ready. So if someone calls it, it's going to always be theirs. But you have to pay for it. And also don't forget this, that with provision concurrency, you don't get init phase for free. You don't get cold start.
Okay.
So if it's like 60 seconds to start it, and you say, like, I have 5 of them, you're gonna pay for all these 5 starting. So that's a big problem. So
just a second, Goran. I think Marin has a comment here. This maybe you can answer this. There are lambdas with Spring framework.
Yeah. I mean, people are working in lambdas with Spring framework, and Spring is also jumping into this wagon of building native code. It's not there yet. It's a performance of Spring lambdas it's far worse than Quarkus or Micronaut, but they're getting there, and I hope they'll get there, because their code is really dynamic, too much dynamic. It's not easy to make everything statically connected, so they can compile it easily into native code, but they're going to get there. So what I wanted to show with this, just want to explain people that there is some kind of initialization phase that we are fighting against. We need to get this phase to finish as quick as possible. Because when someone calls a website, if that person has to wait for like 10 seconds, you're losing your website. No one is going to get it. So we need to, even if the next time someone calls it is going to get the response in like a millisecond, doesn't really matter, because if no one is coming, and in 10 minutes, if someone comes again, there's going to be a cold start again. And also, if you have a high concurrency, like if you have 5 people opening the website, all 5 people, if at the same time, will get this same 10 seconds. So these applications and Lambda containers are not running in multi-threaded manner like people that work in Java used to work. So there's only one threads are already determined, by a router for Lambdas. So it's only one thread. Okay, you can write threads in Lambda but if you have to process something, you can get like 2 cores or something. Right. But it's a kind of a tricky question. How many actual cores do you get, and how many processes can you run in parallel with this? Anyway, so we are fighting this cold start. Okay. And then after the cold start, we have this kind of a warm start. That's your application that you're invoking something. But the problem is that there is Java, a virtual machine, and everything that it brings with it. But there is also your code. If you do some stuff in warm period, in woke period, and then if you're doing it dynamically, someone will have to wait, for that to be finished. So let's say you have some configuration. Don't load your configuration in invoke part of the system. Try to if you're not ready for this that we're going to talk today, load the configuration in the cold start period, because you're going to get one full CPU, and it's going to be faster. Okay. Today we're going to learn on how should we get everything ready in the compilation time. Okay. So
there's just a quick question before we continue from Marin again. Did you ever compare memory footprints between Node.js and Java Lambda for the same job? My understanding here is with the Java would be a less memory footprint if we compile it, right? Okay.
It's a tricky question. It depends on what do you load there, But if
that's the answer,
Java, it's not Java. It's like your libraries that you have to load. Everything that you have to load dynamically, and then we'll see what's the difference. If you have an XML parser that does some XML, extremely complicated XML file, it can add extra 80 megabytes from into Java libraries, memory. So it's just nothing. And if you do that only in just to get your configuration, you can also do that in compile time. So once you get the configuration, you don't really need it later. But let's go to the next step. I just want to mention 2 very important things. If you have to watch something about Lambdas in Java, please go and watch Stefano Bugliani's presentation about Lambdas in Java from the last reInvent. Okay, it's not really covering all these new things that we are going to talk today. It's full of explanations of why and how things work and what are the problems, And also, if you want to get more about these 10 seconds issues and how it works, check Michael Hart's tweet account, and you'll see some of these links to Medium posts, and I have some links at the end. Okay. So about Java, it's not about the Java, it's about developers. And there are a few things that we have to mention here. It's one of the things is reflection, where you can have one object dynamically. Someone gives you some code, but a bytecode, and it's you as a provider of application server. You can ask that code, what functions do you have inside, and then you can call one function by name or something. You can dynamically do that. So if someone can plug it, add some bytecode, you can dynamically load that. So people are used to do that in Java, because who cares if Java server starts like 5 minutes? Okay, what's the problem with 10 more seconds? It doesn't really matter. So that was the whole logic behind it, and now we got into problem. Now that we have so many things already built, and with that goes a dependency injection. You'll see that in examples and class loaders that load stuff when you need it, you know.
Mm-hmm.
But if we know already what we need, why don't we do that in build time? Okay. And also, of course, configuration, as I told you, that's one of the things like that we need to take care of, because if you have a configuration in your main application, you will know how to put these parameters into your code or load it or make it somehow static available to you. But what if you have some dependencies, like someone's library has its own properties or some configuration of how to map objects and database,
Right.
like Hibernate or something? Then you need to load all this configuration dynamically. Okay, why don't we analyze these configuration files, make static code, compile that code, and put it in production? You know, so that's the catch. Okay.
Here's a question from Bokyo. What about other JVM languages? How does this apply to those things?
Yeah, I mean, there's a lot of work on Kotlin. That's that's one, but that's the first thing that if we look at GraalVM, which is that machine that comes at the end, there's a support for any kind of anything that runs on JVM, you know, because we use bytecode, you know. But you know, if the developer is bad, if that developer doesn't do all this stuff, you know, and then if someone doesn't provide you with the framework to do all this stuff to prepare this code for compilation, if you don't have a proper compiler, then if we get the bytecode, it won't be easy to get the final solution properly, you know.
Fair point.
So the catch is there. So Darko, let me explain this a little bit. You have Java virtual machine with that can run this bytecode.
Okay.
And then you have Java as a language. You can compile bytecode, but also you can have a Kotlin code compiled to bytecode. Okay, you can run Ruby inside virtual machine. So you can.
I didn't know that. That's cool.
So you can compile many things to Java bytecode and then run it anywhere, you know. So that's the catch. But the problem is that the compiler is what we are fighting here now. We need to do something at compile time before the bytecode. So
cool.
I would think that there's going to be a lot of work on Kotlin. And also
it's a popular language now. I heard a lot of people talking about.
Yeah, because Google is pushing it on Android side, you know.
Okay.
You know, many of these ideas that we are going to talk today is many of these things are actually born in Google. You know, like there was a popular framework called Juice or something. So where you can prepare everything before so it can run fast. You know, because on Android you have also Java virtual machine. But it's not the same one. It's a bit different. But if you want to run these things really fast, you need to do something before. So many of these ideas are coming from Android world, you know. So
here's a tricky question from Michal.
Groovy is popular, and you know many of these things are. But if there's no proper compiler, we have a problem. The question is: isn't Docker an ultimate solution for the JVM problem? Well, no. I mean, you'll see that right now. I mean, just this is it. And after this slide, we're going to code, and Docker is part of the solution, you know. And so, what's the solution? You know, we need a smart compiler that can do the static analysis of the code. So, imagine this: like you have a lot of Python code, and then you call something and instantiate something in the code, and then you make a big tree of connections between your main code and dependencies. And once you spend all this time in the runtime loading it, take a map of all these things that you just connected, you know, and then ask yourself, what do I actually need? And can you go through that map and pick only the functions that will really work for the function that you are building right now? Because if you're doing that for serverless lambdas, your target is to get that one function running. You can have like 1,000 functions in the project, But that one function is only doing that part of things. So it doesn't really matter what else do you have in that project. Yeah,
correct.
So you need to go through that tree and get only these things that you actually need, and make that connections, and then put that into native code. So that's the whole idea.
Okay.
We should avoid lazy loading, but not in terms of the things that you need in production. For the things that you need in production, okay, that will happen later. Okay, that's fine. I mean, you have to go connect to some website or something. That's fine. But if you know something, take it before.
But here's the thing, like you mentioned to me, we discussed about dynamic loading, how great it is that you can dynamically load different classes or whatever. And here there is no such an option. I mean, you map dynamic configuration and compile it to binary. Yeah. But I guess that's not a problem here, right? Because it's a Lambda function. It does just one thing. So you don't have to think about dynamically loading new features to a Lambda function.
Yeah, you know already what your function is going to do. You know the configuration. You know which database you're connecting to. You know everything. So this is the general idea of where we should go. And let me give you one more example, and that's one of from some of the great videos about Quarkus, is that video was about Hibernate, and then there was a great example of a MariaDB driver. MariaDB is a MySQL compatible database, and there is a driver for it, and there's a standard called JDBC for all Java database drivers.
Okay.
So when they were compiling it, trying to see what's really needed, they realized that the driver is actually using something called JavaFX, with all 2D and 3D components in it, and all the dependencies, everything that's inside JavaFX had to be included in your project if you just wanted to connect to a database. So why was that? Well, if you are connecting from your desktop to a MariaDB database, and you put in the connection string your wrong password, well, application should show up your username and password so you can enter it. So all this for something that you don't need in some environment like Lambdas. That's something that's going on servers somewhere else. So if it's a wrong password, it will break. That's it.
So that's why there's a lot of Java code. Well, why Java code is so large, because it loads on completely unnecessary things.
Yeah, I mean, you need to put everything in your library. It's the common problem. You have a library that's adding features. And after 10 years, you get some giant library. So that's the problem.
It's like node modules. It's like Node.js node modules directory.
Completely the same. I mean, bad developers in Node.js are even worse than bad developers in Java. So that's the problem. Yeah. So let me go to the next example.
And there's a question from Martin again. That you should run Lambda functions with Java without frameworks. Only some utility libraries.
Yeah, I mean, definitely you should cut off some extra dependencies that you don't really need.
Okay.
But if you use these tools that we're going to talk today,
it's not a problem, right?
Yeah, then these tools will solve it.
Okay.
Yeah. So someone is joking. Yeah, everyone is bad. So I'm saying that. Yeah, we are all making bad code, and if we just continue doing bad code, then we'll end up with things like this.
And here's the thing: like, bad code is so. If any of you have ever programmed in the long ago time, like for a very small, like old computers, right? So you had a very limited amount of resources you can do. You had to be a really good developer to make good running applications. And all of a sudden, we had these massive servers available, this entire compute platform that we can do everything with them. And you can literally make bad code and it will run fine, right? It will run fine. I mean, people, a minute here and there, people that nobody notices in starting your application. But now we're back to doing highly optimized things in Lambda, where we want to make sure that our Lambda functions and our serverless applications are run short, so it can say cheap, and also be very fast because we want to have that instant reply to customers. So that's why we want to make sure to have a good code. So Goran will show us some bad code now.
No, I'm gonna start showing you where we're going, in which direction. So let's see. We have one simple Java class that's gonna print hi Darko. Okay, so
Hi.
simple and nothing else. You don't have any dependencies here. This is just a simple application, but still it will run on something. It has to run on something.
Okay.
So if you want to compile it to bytecode in Java, you would do something like this. Now we have two files. One is Java file code, and then the second one is bytecode. Okay.
Okay.
So then we have to pack these. Generally, whenever we do some complex application, we pack them into something called jars. It's actually a zip file, nothing else. So we have a demo jar, and if we just want to run it on the Java virtual machine, you would do something like this, and it says hi Darko. Okay.
Hi. Okay.
So that's it. So you have a bytecode, and you run it on a virtual machine. And but let's go a step further. So let's use something called GraalVM, or technology by Oracle, and let's compile this into a dynamically linked executable. What does that mean? Yeah. So let's say this is a compilation that will just try to compile this bytecode into this executable.
Okay.
But still, this executable is a Linux executable. It requires you to have something on the platform where it runs. It requires some libraries. Okay, so let's check what's inside this library, inside this demo. Okay, application. So this new executable called demo has some dynamically loaded libraries. So that means that I can copy my demo application, but there where I'm copying it, I'm expecting Linux with all these libraries to be there. Okay.
Yes.
So that's fine. Okay. So if you're making a Docker, you can start from a Ubuntu or some other Docker.
Containers.
Yeah, and then you can add these executable, and then you will be probably fine. You will get this executable running, but you still need Linux to start. Okay. So let's start this demo. And
what is the footprint of this one? So so the one that you ran in Java, can we this is how big is this one? Oh, it's 7 megabytes. Okay.
It's just so small, and the jar is so small. But this binary is a little bit bigger. Okay.
And does the binary have the entire JVM inside? Does the binary have? Oh, okay.
That's the catch. Okay. But so if you're using just Java, you have these 749 bytes. Okay.
Bytes, yeah.
But then you have to add extra runtime for Java, which could be 80 megabytes or something. Okay. It's not a big deal, but it can be a big deal. Okay. The size. Okay. And many of these things from Java needs to be started when you start this thing. So the startup of Java is not absolutely zero. It takes some time to load something, configuration or environment stuff, or many old things are still in Java. So we have to remove them to get here. But the process.
Bokeh has noticed something. 2 gigabytes. Hello world. If you scroll up, there's a 2 gigabyte something on the side when you did the compilation. Is that memory usage when it was compiling? So if you just scroll up with on the terminal, say 2.26 gigs, is that just how much memory it consumed, the GraalVM, or I guess so, yeah.
So here these things, I'm not really sure. I would say something about that.
Some RAM usage.
Yeah, that's something for the compilation process. I'm not really sure about how can I. Yeah, sorry, I'll need to check that.
That's fine.
What was this process doing is it was taking only these things that are really necessary, and then from GraalVM there is a part called substrate VM. It's a smallest possible virtual machine, which
Okay.
has only garbage collector and a few things more, but that's it. And then you add that substrate VM to this. So it's not really a virtual machine. It's just a helper for this application. Okay.
Got it.
So that's it, and no Java stuff in it. Only garbage collector and the simple one. Okay. So, but this library still requires some other. This executable still requires other libraries to be in the project. Yeah. So like it's a 2 days old release of GraalVM, where you can actually compile this executable to a completely static executable. Okay.
Oh, interesting.
So I prepared everything regarding libraries here, and let me show you how it looks like. The command is very similar. So we are just building a static one and using this library, which generally used in Alpine Linux anyway, and then we'll get really a static executable.
Then you get a completely full binary. Of course, it's a Linux binary that you need to execute on a Linux system, but it has no library dependencies locally, nothing.
Zero. So let's see what's inside it. Not a dynamic executable.
Amazing.
Let me check. It still prints high Darko. Okay. So
how big is it? How big is it now?
Yeah, I mean it's. I think it's almost the same. Yeah, it's almost the same.
It's the same. That's the same. All right, that's fine.
Not really big difference. But what we can do now, we can now do something like this. Let me show you. So if you're building Dockers, you will love it. Can you see this?
Yeah. It's make it just slightly bigger, but yeah, bigger is fine. Yeah.
Can there be a smaller Docker than this? See,
No.
From scratch really means from zero. There's nothing below it.
Wow.
There's no layer below it.
It doesn't use any image. I mean,
that's it. Darko, that's it. So if this application is a small web server,
yeah,
it will just do the web server. If you put if you connect that application to some database, it will do everything, but it will be all statically linked. That's a great thing,
Wow.
So when Bokcho, I don't know, said just 2 gigabytes hello world, it's a few megabytes for it's not gigabytes, it's megabytes here. Yeah. So it's a few megabytes for this substrate VM, but then the rest of application is only what you really need packed into this, but really need. Okay.
I think this is cool. I mean, especially if you can run a Docker container from 3 files without any additional layers on top of it. Wow, that's very cool.
So what's the catch? When you put this when you deploy Dockers, you need to say, okay, I want a Docker like with 128 megabytes or something, or you can go as low as it's possible. It's very low memory consumption and the CPU consumption and everything. It just gets lower, because you don't need any of these things, and also the process of building it. Building new Dockers, that's it. There's no other dependencies. Okay, so it's the only problem now is that this compilation time it takes more time, and you will see that as we move all things dynamic to a compilation time, we will spend more time in compilation. Okay, so that's the problem. If we have a CI/CD process, that is we make a slight change in our code and deploy it. If we have to wait 30 seconds or something for every single Lambda, then the build time for a bigger application will be really high. So the catch is, you should, and that's what we do in production is for development, you should just use pure Java. You don't really care about if it's like a 1 second, 2-3 seconds cold start in development. If it will work the same, Then when it goes into production, you will use a different build that will produce native libraries, which will run faster. So that's the catch. It's not good if you have to wait for 30 seconds.
Absolutely. And here's a question from Bokyo, and this is very interesting because I know when you run jars in Java, you define memory minimum and maximum. Is that being completely offloaded to the operating system now if you compile this Java code into a native Linux binary? Or is that not the concern here?
This is a native Linux library.
Yeah.
There's no limit. Cool. Now you're in a problem. You have to take care of this.
Yeah.
There's no Java to take care of this.
That's very cool.
But it's fine.
Forget your Xmin and Xmax. And also regarding Lambda layers, I guess, this you can. I don't see a reason.
We'll get into that later. But this first example was only about compilation to native code. Okay, and if you're doing Kubernetes, doing any Docker stuff, ECS, if you can stop here. You can finish most of the things here. That's it. You can have a native one and then pack instead of packing 10 projects into one host, you can now maybe pack hundreds of them. That's right. A big difference. You can start them faster. In terms of how Java actually works, you may end up having a slower application. That's a really thing to think about. So JVM is a virtual machine which is really smart. So once you start your application, and it takes a bit more time to start it for the first time. Yeah. But then it will manage the memory, the usage, the caches, everything for you. So all the applications, all the requests that come later to a virtual machine will actually work faster in most cases than with native code, because there is this super cool management that Java virtual machine has in native code. Okay. So, when we compare how most of the applications work, so let's say a typical example of a REST request. Someone is calling a website, and in terms of such requests, there should be no big difference how the code works. So you will really get a great benefit. So, but in terms of if you have an application that is doing a lot of calculation, like
something long running,
Fibonacci, whatever, prime numbers, whatever.
Prime numbers. Yes.
You stick to Java. No, don't compile to native, because the startup will kind of be slower, but then it will be faster. You will see the difference. Okay. So one more suggestion is if you want lambdas which are for like a front-end lambdas that users are going to compile them to native, because the response for that first request is really important. Okay, if it's a lambda that's running something from a queue, from SQS, SNS, it doesn't really matter. That 1 second cold start it's not really important. So you just ignore that fact. Okay, so let's go to another example, and with lambdas. So it's a demo too. So the goal of this example is to have Lambda running in production. Okay, so I have prepared this project, but I will show you later how these projects are created from Quarkus. Okay. Quarkus is a tool more than a framework, coming from Red Hat, and there is another one which called Micronaut. It's coming from another company, Object Corporation, whatever. Okay. And these two frameworks are fighting in this game right now.
Okay, so Quarkus IO and Micronaut. Okay.
So I'll tell more about differences later, but the biggest difference and the main reason why I mostly use Quarkus is that it's more tool than a framework. It actually allows you to use existing frameworks more easily, and then just to connect them into these projects.
Okay.
And, so yeah, let's see the project in Quarkus. Okay, so there's a few things in this project. Maybe I can make it bigger.
It's okay, I guess.
Can you see this?
Yeah, that's fine.
So a few things that we will show now. First of all, let's see what's the request. This is going to be our payload. We're going to send this. Okay, to the server, and then there is an object, and in Java you usually you do things like this. You have a JSON, and then you have a JSON parser, and then you automatically make an object.
Okay.
And this input object is mapping this name and greeting coming from this JSON. Okay. Then there is our Lambda. This is Java Lambda. Okay. This Lambda has. This is all coming from AWS. You see, these are the libraries. These are the requirements for this class coming from AWS. And this handler, this is a function coming from AWS. So this is what's required. Okay. But this Lambda, when it receives this input from this JSON, it will send it to something called service to process it.
Right.
Okay. And this input is that's the object that we just created. So what's this service? Service is actually injected object.
Okay.
That we can call here. So what's the processing service? It's another class that has a process method that we can call, and we will call it, and this is what will happen. We will just print the greeting and then the name. That's it.
Okay.
But when I talk to you about this dynamic stuff, you see, this is one of these beauties of Java, where you can say, okay, I want you to inject me here this object so I can use it. So it will instantiate it, it will connect it, you can parameterize it and stuff like that here, and it will automatically connect it. Okay.
Okay. Yeah.
The problem with Java, as I told you, is that it's usually done during the runtime.
Right.
And it takes time, because during the runtime you need to go through these classes and check them, and then find the method and then call it. So this costs a lot, And the one of the biggest problems with Spring is this extreme dependency on these dynamic things, which is great, and we need to keep it in code. We need to have these abilities. We should not remove these things from code, but we still need a way to compile it. Okay.
Goran, can you just minimize all other windows, because Visual Studio Code is glitching here. See that? Maybe if we move all the windows, because it's apparently this one is it's a bit freaking out. So I'm not sure if this will help-ish. Maybe Sublime. You have Sublime still going?
Yeah.
Okay.
Is this better?
It doesn't glitch anymore. There we go. Interesting.
That I have this paid license for Sublime, so I hope it's not. If you pay, you get these extra problems. You
get glitches.
Oh my God, we have some glitches still. But
no. Maybe because you have something open on the other screen, but it doesn't matter. I guess we'll get through this.
Okay,
that's better.
So let's see. One more thing to understand is this thing that you can see here is an annotation from Quarkus saying, well, this Lambda is Lambda which will have a nickname test. Okay. So in this same project, there are other Lambdas, like Stream Lambda. It has a nickname Stream. And there is another Lambda called Unused.
Okay.
So you can have one project with many Lambdas. And then in compile time, you will tell the compiler, okay, I want you to compile this one Lambda. And it will find these connections, dynamic connections, and then produce code with only that. Okay?
Got it.
So let's see how it works. So let me show you this. So we are here, and now we're going to do some stuff. I need to set my Lambda role, and this is, I don't want to explain this too much right now.
This is defining a role that your Lambda function will be using.
It's required for this deployment process and stuff like that. So let's see a few things. We need to clean and then package it. So what I call just is it's Maven. It's for Java developers. It's the most common how I call it.
Compiler?
Builder.
Builder.
Yeah.
Okay, builder. Okay.
So it manages all the dependencies and stuff like that. So this is that's the first thing. Okay. So no glitches in this. So
glitches.
Yeah. On this terminal. So okay, I just compiled it, and what we get now, it's in target folder. Target folder, we have some lambdas, and then you will see they're all packed at the end in this function.zip file.
Got it. Okay.
There is a slight difference between jars and zip. Okay. So AWS would like us to pack everything in these zips, instead of using jars, So it's just a slightly different, and but it's faster for AWS to load the zip and unzip it, in a way these things are organized inside of it, instead of unpacking jars, because the structure is kind of a flat structure instead of this kind of libraries and stuff that the jars usually do. Okay. So it's faster if you prepare zip. Okay. So there are Maven packages for you to produce this, but
now in this function.zip, this is your entire compiled code base now. All the functions.
Yeah. But this is not native yet. This is
not native. Okay.
First we'll make this. Yeah. First let's make Java and see how it works.
Okay.
So I'm going to call some scripts that Quarkus provides here. So let's see what it's doing. So I'm calling AWS to create a function called Lambda.
Okay.
I use a zip file.
Okay.
This is the default handler for Quarkus.
Okay.
And I use Java 11 runtime with this execution role with memory size 256. And the response from the server was, okay, this is created. Okay.
Good.
So that's it. Now we have a function there. It's Java function ready deployed in AWS. In my account.
This is a native Java function.
No. This is still Java.
Okay.
Java bytecode. So let's call it. Let's call it and see what we'll have as a result. So the result is, okay, I send them hi and serverless in some JSON, and then I got response that I said we will concatenate a greeting and the name. But let's see what we have here. Init duration is 1.6 seconds.
So it's a cold start.
That's a cold start, yes. Then we have this part, which was invocation. Our handler did. It took him 120 milliseconds to finish it. But look at this. Build duration is 200 milliseconds.
Yeah.
This is just because duration was like this. So we are not charged 1.6 seconds. Okay.
Good.
So let's call it again. Now it's hot. It's there.
Yeah.
Let's see what result we have. So now it takes only 1.1 millisecond to run. Okay, 1 millisecond. That's normal. It's running. It's an application which is running, waiting for our requests. It's hot. Okay.
Yeah.
And you see that build duration is 100 milliseconds. There is no cold start.
Got it. Yeah.
This one is called. So what if I do it again? I will have, you see, less than millisecond.
Less than a millisecond.
Less than a millisecond. But this example is really simple. It's just using some code, some text, no connection to VPC, no database, stuff like that.
It's a hello world application, basically. Yeah.
Yeah. So let's see what we can achieve. Just let me delete this one, and let's build the native one.
Okay.
Okay. So native one goes like this. So we call this Maven package. It compiles it. First it prepares it. Now it compiles it. And now
when you say native, it's the one which has it's a statically compiled thing, or
no, this one is like that one that was dynamically compiled. But don't forget that Lambdas run in it's a Linux, Amazon Linux, so it should work, So it's not a problem. And
we see the compilation now. Yeah, I see all the things that's happening.
Yeah, the similar one that we had before. Okay, it took 33 seconds for this to compile. Very simple example, But don't forget, we only compile that one path for just one.
Yeah.
For just one Lambda. I'm saying that because it's important to understand. Let me show you. Let me show you the. Where is my code? Sorry. So let me show you this. So in sorry, where is that? Where is that? Settings. So by default, application compiles only this Lambda, which is called test. Okay. And let me show you the example from my production system and from a build script from production system. Then you will understand it much better. So this one is build spec that we're using. So you can see here.
You need to zoom in. We don't see anything.
Sorry. Let me see if I can zoom in. So this is the build spec.
Right.
The build spec in CI/CD process. So you can see here that every single Lambda with its nickname. This is the nickname.
Right.
Oh, sorry. This one is the nickname.
This is the name,
Yeah. So I'm overriding that property and compiling it. So if I have one giant project with 10 Lambdas in it, the system will, for every Lambda, it will go through its traverse through this tree and find the least amount of dependencies that it requires and compile it. So that's the catch. This is how we keep one project together, libraries together. That's important. So if you have many libraries, your own libraries, you don't have to make one repository per Lambda. That's so hard. I mean, that's too much. But this is how it works. You have one project, and then you can compile many Lambdas from it. Okay.
Yeah. And what's great about this is an actual real world example. It's not me doing a hello world thing. Goran runs this in production. So the things he's saying today actually apply to production systems. So
well, I also prepared one view from a dashboard. This is the screen from also the production system. You can see here. This one is, I think, for the last couple of hours. It's you see these green lines.
Yeah.
This is the maximum duration of Lambdas. So it's Lambda. This one is. When you call this server through the API gateway, it calls SQS service. This one, this particular one, and you see that from time to time it has a cold start.
Got it. Yeah.
It takes more time, so it's like you see, it took 3 hours for the next cold start.
Right. Okay, that's cool. That's cool.
Yeah, you see the average there.
Yeah.
It's 45 milliseconds,
Yeah, nothing.
That's the Lambda that is receiving a request from API gateway and calling another service in AWS and doing a few more things, and then closes and returns some feedback. So this is the real example of Java and Quarkus Lambda in production and every day. So also you can see that cold starts happen in the same time, where you can see that in this example, where you can have like more of these concurrent executions. So if we have 3 concurrent executions, like in this case, see, then it's obvious that one Lambda that is running from time to time is not enough. We need to start 2 more.
Yeah.
So that's what's going on here. Yeah. So let's go back and see how our project goes on. So this is we just built the native Lambda. Let's create Lambda. We actually now we are creating Lambda, also function, stuff like that. Okay, and it's now deployed. And now let's invoke it and see the difference. So,
oh wow,
init duration 234 milliseconds. Okay, so this is the cold start from 1.6 seconds. We got to 200 milliseconds. You know,
yeah.
but
Wow.
In production, the differences are even higher. You know,
Exactly. This is massive. I mean, especially if you have a more complex Lambda function. Again, this is just a whole world of Lambda
as
function.
system goes, gets more complicated. Native Lambdas stay in this area of 200 milliseconds, and that's what's
amazing. That's amazing.
Yeah.
Wow,
but
we cut the initialization time by a lot of percent here.
Yeah, that's it.
Wow.
That's it.
Couple 100%.
Yeah, this is something which I would expect from any language. I don't expect that init time can go really lower than 100 milliseconds.
Of course.
100 milliseconds. And also these numbers are not fixed. You know, you have to understand that this is coming and going. So, but there is one problem here. Okay. There's one problem. This is not documented, but check this. What was the build duration?
300 milliseconds.
But why? If we had only 3 milliseconds Lambda running.
Huh.
You know, well, this is because Amazon gives free cold start time only for their own runtimes. If you provide your own runtime, they will bill you everything. Okay. So we are so how much are we billed? The same.
Yeah.
You know,
it also splits the durations, because you get billed. Well, no, you get billed 300. Yeah. Wow. Interesting.
Yeah, but let's see again the next call. 1 millisecond.
1 millisecond. Yeah.
We are charged only 100 milliseconds with minimum. So the catch is we will be charged the same in this example, but our website will have a response which is almost not noticeable. Okay, and of course you can, if I don't remember if we had this. This is the lower memory being used.
Okay, we didn't notice it last time.
Right. Sorry. Let me check if I can see it here.
Is it available anywhere? Above Maven somewhere?
I did a clear, so
it doesn't matter.
So doesn't matter. But the thing is, you can use less memory for your lambdas. Okay. You can have a much lower initialization time, but still, look at this duration time. The handler was working. It's not much different, you know. But you will notice that even later, you know, when you have this code compiled in native. It's not really big difference, but mostly this cold start is what we are fighting against.
People watching this as a recording can actually go back and see if the memory usage is better or not. So we don't know right now.
So let me clean this and
but that's a massive difference. I'm really surprised. Like I was expecting a difference, right? So you mentioned to me it's faster and all that stuff, but the initialization difference is massive. Like that's 500% better.
That's the biggest problem, you know. If you're making a website with that's why people are complaining mostly about this. How much time do you need for your API to get the response? Okay.
Got it.
So let's see the third example, and this one is about REST interfaces. So let me show you how it works with Quarkus to get this running. So you put this. You can call this, and it will initialize the project for you. Okay. And
what are you doing right now? What kind of this is with Quarkus IO?
I'm creating a third project. Okay.
Okay.
I don't know, one doesn't really matter much. Anyway, so now I have a project structure here.
Okay.
And I'll do something which is missing here in this project. So ignore it. I'll think that they will fix this. So let me show you the structure now in the project. It's yes. So
can you just minimize the window in the hand so it doesn't glitch out here? Yeah. You can just minimize it, I guess.
I think this is also the problem.
Yeah.
Okay.
Much better.
So let me show you what are we targeting right now. So we're targeting something which is a typical implementation of a REST interface in Java.
Okay.
So this is also a great example of dynamic stuff that you can do in Java. So if we define this on this class,
okay,
this means that the server, I mean Java, whatever, will start the web server, and then it will connect the web server with this /hello.
Got it.
Automatically. Okay. So whatever we do here, it will automatically be affected, by in that way. So let me show you what we do here. How you do development in this. Let me show you. How do we do development in Quarkus? So that's so you call this Maven Quarkus development mode.
Okay.
It starts this development mode. Okay.
Okay.
So it starts a web server because we have this /hello in it. Okay. And then I will open a web server, and then that web server should started somewhere. Let me find my Firefox.
Find your browser.
Yeah, just a second. It's not this one. If it's not this one, let me open it. 0.0.
No, you have to do localhost. You cannot do zero.
It's the same. Don't worry.
Okay.
So we have /hello.
And
then it.
Can you zoom in a bit? We don't see anything.
Yeah. Sorry. This is the response. Okay. I'm not sure if I can. So this is /hello.
Yeah.
And because this function works like this, it returns hello JAX-RS. Okay.
Okay.
JAX-RS is the short name for this whole technology.
Okay.
For REST technology in Java. So look at this. So in Java is interpreted or compiled.
Compiled, yeah.
Yeah. So look at this. So if I say hey, hi Darko and save it, if I go here, it will automatically compile it in the background. You will not even notice.
Wow, that's very cool.
So this is how development in Java looks like now. You can do many things. If you watch videos about Hibernate and Panache and stuff like that, these terms in Java, you will see examples where people can change like a property of a class, and it will automatically change the database which is behind it. So there are many really great examples where you really dynamically code. You don't really do compilation, and you don't wait for any compilation and anything. So this is that's it.
Wow.
If you have a giant project, it will take zero time again. Okay.
I thought you always have to do like Maven or Gradle or something like that. When you do with Java, you have to compile.
Yeah, it's actually happening, but it's because these intelligence compilers know what to add. This is so fast. this is incredibly fast. You cannot make it any faster. So let me show you what you can do here also. So if I add some, this is how it looks like, working in REST and dynamic stuff in Java. So let's add like name, and let me add pattern. Name. Sorry.
That's okay.
Name. So let me show you this. That I save it. You see what I was doing? I just added /name, added a parameter, and that's it.
Okay.
It
So
automatically it will
automatically
do everything, you know. So it's Darko.
Mm-hmm. Wow.
Darko.
Cool.
It's Goran. It's Goran. So it works, you know. So that's the catch. So it's you see why it's so beautiful to work in Java. Do you have any?
I like it.
Can you compare this with Python, man? This is it.
I know. I'm not saying, but for me, Java code is very scary because a lot of the scaffolding that goes around it, but then a lot of the big folder structure, which I'm not just not used to it. So no shade on Java.
You can see here when you look at this, you understand it. This is automatically wiring a lot of things dynamically. You know, so you can. Now you don't really have to go to some configuration and put there this / something goes to this class and does call this function and other stuff. So well, we have this project, but we have this interface in REST.
Okay.
And it works, you know, but you cannot call lambdas directly through a REST interface just like that. You know, there is a
exactly. You have to have something in front of it.
Yeah, you have to put something in front of it. It's API gateway.
Yeah.
API gateway doesn't provide you with the web server that understands REST. You know, in this way that it will map these parameters here. So what is Quarkus doing? You know, to help developers, you can keep this exact style of coding, but we will provide you with this. Remember this bootstrap that we were talking before, you know. So we will provide you this bootstrap that will provide you a small web server for you. So when you call API gateway and it calls Lambda, it will map everything for you. This input request from Lambda, which is not REST, you know, that's some packaged message, you know. And it will pack it for you as a REST request in this way. So you don't have to change anything here. Okay.
So it's another layer of abstraction between the API gateway, the Lambda function, and your code.
Yes.
Oh, okay, interesting.
It's a repacking, but at the end, what you get is that you can develop your code locally and test these REST interfaces, and then you can deploy it in production. You know, it will just work the same.
Okay. That's very interesting.
But
like
with another front end as an infrastructure, you know. So another front end, API gateway. So yeah, let's try to compile it and package it and see how it works. So in general, you should expect. So we will now build it.
Martin asks provision on an API gateway.
Let me show you. Oh, so look at this. So the test failed. You know, the test failed because we changed something there. So let's go back and
test-driven development, folks. Very important.
Yeah.
Write your test and you write your code.
Yeah, let's see the test. Our greeting test failed because, you know, it was expecting something like hello Darko, and I should say here hello Darko.
Got it.
So anyway, it will just work like this. I hope so.
So Marina, it will not provision an API gateway per se, right? API gateway will have to be provisioned by you. I think if I understand this correctly, this is just a translation layer within Java itself that translates the requests coming from an API gateway to your Lambda code that Java can understand. So
let me show you what's going on here. Quarkus is smart. This extension for Lambda for Quarkus is smart enough to provide you with SAM template. Okay. So if you look at target folder, you will see that it has SAM JVM YAML file. So let's look at it. It's called target SAM JVM YAML. So it has everything that you need to deploy API gateway. Okay. So look at it.
Amazing.
Definition of Lambda and then API gateway.
Yeah. So Marina, this is the answer to your question. It actually maps the paths for you with SAM if you do it this way. So
you see,
amazing.
/proxy on API gateway will do this for you. Okay. So let's deploy it. Yeah, let's deploy it. So this is the command to deploy it. And first we have to package it, and as SAM works, you have to package it and put it on some S3 bucket. So once we package it, it's there. It's ready on our on a bucket, and then I will now do the following and deploy it using template.
SAM deploy, okay.
Yeah,
so and then SAM deploy to deploy the infrastructure.
To be honest, in production we don't use SAM. We use CDK completely for all deployment of Java stuff, Lambdas. So, but this is for this example, this is cool, and
but you can do it manually. It doesn't really matter. SAM is here just for
doesn't really matter. Once you have this Lambda, that's it. So what's important in this process is that if we are building a special runtime, we need to deploy runtime, not only Lambda. Okay.
Got it.
So in this case, there's gonna be a runtime deployed with this. That small runtime which will provide this connection between the API gateway and this REST server, which is called Netty. It's a Java HTTP server, and there's a connection between these two. Okay, so also in our previous example, we had a Bootstrap Lambda. Actually, I can show you that later. But the whole Lambda was actually put into Bootstrap. So there is no Bootstrap plus Lambda. You know, it's because it's not really. If you make a runtime per Lambda, you know, because it's small and you don't really need separate Bootstrap and Lambda. You just finish it in one step. Okay, now we have stack deployed, and here is the address. This is the website. Okay. We have an endpoint. Sorry. Link. So if I open this endpoint in my browser, let me show you this. If I open it in my browser, so we had something /hello/something, and now if I provide you with this address and /hello/ Darko Tsar, there should be something, and so there is a cold start here.
Cold start.
You see?
Wow.
We have a response from the server. So once if we call it again, if we do something, it's just super fast. You don't really need to wait for something. But you don't have to change your code. If you are familiar with the REST interfaces, that's how you should do. Okay. So so these examples are all guiding you to direction that you should prepare your code by using these tools and frameworks and compile it to a native code at the end. Okay, but even if you don't compile it to a native code, if you can use some of this tooling, you will get faster Lambdas. Okay, because many things are moved from being dynamically loaded to being statically connected to the system.
Okay.
So you will automatically gain some things from this. So how does it look like for you? Is it? Do you feel it complicated for you if you're not coming from Java?
So
this
you made it very clear for me, because here's the thing: like I don't know Java. Like I've seen Java twice in my life, and I was always under the impression it's became a meme that, oh, Java is this big clunky thing that you have to have a lot of stuff on, and it's not really for serverless because it's. But I mean, looking at the examples that you've shown here, especially the compiled ones, it's like it's fast. Like it takes only a couple of like less than 200 milliseconds to bootstrap a cold Lambda, and it just works fine. Plus, the development environment with Quarkus and it automatically compiling during execution is really cool as well. Beside me just being scared of Lambda of Java as a complex piece of code, I think this is very cool, and I found the explanation quite good, Goran. Here, I do think it's amazing. Well, it's great how you can compile it to a native statically linked application, and I'm a fan of those. I like to compile and statically link everything because then you're sure it works.
Yeah, I mean, if this is not only about serverless lambdas and stuff. This is also about Kubernetes and Docker and stuff like that. So whatever you do, if you can make it smaller, that will automatically enable you to deploy it in a much faster, in many much more. When you need new version, you will be able to much easier redeploy it, restart it, fix it, or something. Okay.
And remember, kids, it's not Java, it's you.
Yeah. So but let's see. In these cases in these examples that we are talking, we discussed a little bit about. Let me see if I'm on the right slide. Yeah. So we just talked about, okay, you can use something which you already use, and it will just compile, and that's fine.
Yeah.
But in reality, there is a giant effort from people from Quarkus, Micronaut, and other guys to make a lot of extensions to this. What does it mean, extension? So if you have something which is, let me give you one short example of that.
And just a quick answer to Michal. Is there any difference, Oracle Java versus OpenJDK? I believe you're running this in Coreto now, so it doesn't really matter, right?
Yeah. If we are talking about using Java, you can do you can compile it anywhere, and when you run it in AWS, it will run in Coreto. If it's there is a still version of Java 8 which is not Coreto, but in general you can now, as a few days ago, you can pick version which is also Coreto 8. So Linux, Amazon Linux 2 plus Coreto 11 or 8. But if you are doing stuff with GraalVM, that's Oracle's. Okay, it's and then but at the end you get the native code. There's no Java, so it doesn't really matter. Okay, it only matters that you have Amazon Linux in the background. So I mean, the problem is that it's Oracle. Okay, so Red Hat is actually creating an open source version of GraalVM, which will have, so you can be like more confident. So, but doesn't really matter. If something happens, you can always compile to Java and have like a bigger cold start, and that's it. But in terms of licensing, there are two versions. GraalVM comes in two flavors. One is this open source and public and free, and the other one is enterprise version with support.
Okay.
But also some, there are some enhancements in enterprise version that are coming later. It's not that these things are not really big and it's not really important. But also there's one more thing that's important, that in Java 13, Java 14, things which are coming are really important. There are many things that will come in native, just in OpenJDK. that will allow you to make some of to generate this static information. It's called CDS, class data sharing, or stuff like that.
Okay.
There's also a project called Yandex that to analyze code statically. So you don't really need to have all these. You don't need to be worried that you're going to be dependent on Oracle in any way. So this is pretty clear. So the problem these extensions are solving is something like this. Like you have some parameter which is like something like this. Let's say param1. Okay. And then you have your code, which is working on the premise that you're going to read something from the configuration. Okay. This is how you work now. So you have one file, and when you run the application, you will read the file and then do something accordingly. What does that make? That forces you to have all possible variations of your code there at one place. So you have to be ready for any changes in the configuration. Okay. So what these extensions are actually doing for you? Okay. So instead of having that kind of code, these extensions are converting these things into something like this, like public static param equals, I don't know, MySQL. For example, if which database I'm connecting? Yeah, I'm connecting to MySQL, because in the compile time, it will read the configuration, pick this parameter, and then you will, in your code, it will be if param, and that's it. Because it's statically, it's because it's static. It's going to be final. I mean, that's it. So that's the catch. So if we have this, we will completely disregard many pieces of code that we have, automatically, and then we have a smaller code. So these extensions, this whole effort from Quarkus and these guys is how to help people who created the dynamic libraries, the dynamic dependencies that you have to use, how to inform Quarkus and GraalVM later on which of these how this tree of code can in which directions it can go, how complicated it can be, and stuff like that. So let me tell you, there are two frameworks, as I said. One is Quarkus, one is Micronaut, and they have two a bit different directions. So Micronaut is a framework. It's actual framework. It forces you in many ways to create new code, okay? But it's not that much. I mean, I'm just saying that you need to think again. It's not like in Quarkus where you're just they're making extensions to existing frameworks,
Right.
But in Micronaut, they said, okay, we'll not use stuff like reflection, and then they're rethinking everything and forcing you to make these applications be easily statically compiled at the end. That was not their intention in the beginning. But when it happened, things happened at the same time, and then voila, we have a great product. So one more thing is important, that the whole Java scene is now so hot. Everyone is so excited, and they're so passionate, fighting against each other and saying,
absolutely,
my product is better, which one is better. So it's, there's a link at the end of the presentation about the Micronaut, and you see how these things are important. Every millisecond now works. Like for 20 years, 25 years, no one was talking about minutes, not now everyone is talking about milliseconds. Just whoa. So,
just to mention a comment here by Marin. Basically, he uses Java and Lambda functions, and if using pure Java without frameworks, just some libraries, he gets better memory footprints than just running Node in working with JSON files on S3. So so I think that also shows the fact that you can really optimize your Java even without some frameworks. But as long as you write the good code, it should have a better memory footprint.
Don't forget that when you're connecting to AWS libraries, services, you're using one of the big dependencies. It's AWS SDK, which is not perfect.
Absolutely.
So it's not easy to get it running natively in for everything. For example, there's a still problem with X-ray, and you cannot really get everything in being compiled into native code. It's not easy.
Okay, got it.
They made some strange decisions, and every module in this SDK has a kind of a different strategy where it goes. So I would say that by using these things, you should gain more, because there are extensions for DynamoDB now, and extensions for JDBC, and many things that you use, and you should use it, even if it's a simple. You think it's a simple dependency, but remember the example that I've told you about MariaDB. So it's so many nonsense in these dependencies, So so I would I professionally read everything about Micronaut and Quarkus. Whatever happens, I read it. I think that Micronaut, no matter that I don't use it every day in production, but it's I'm impressed how passionate they are at what they do, and how they want to create a better framework, because experiences with Spring and other frameworks before got us into this situation. Okay, so now they're trying to make it the best. But what's really interesting is that despite being different, and let me explain shortly what's the biggest difference. Micronaut is trying to achieve everything on in compile time in source code. So if the source code is great, then we will have application working in natively better. But Quarkus has an interesting different strategy. It says, okay, we cannot find everything in this tree.
Yeah.
Let's start the application in compile time, and then catch all the dependencies and take that snapshot in a file and use it. So Micronaut is not doing that. They're trying to analyze code, and Quarkus is actually trying to achieve this by using this technique. So I mean, I'm not totally deep into both of these frameworks, tools, so I can.
Which one should be used by a beginner, by anybody who's starting with trying to compile their applications? So should they start doing Quarkus or?
Irrelevant. They're just great. I mean, they have so many great examples, small examples, and they all have examples for AWS. So
good.
It's easy to get your first Lambda there. So I would say that just try both, experience the differences, and then you'll see. But it's also interesting to see the approach the Spring is using now. They are kind of dynamically deciding, okay, which one is better for this project.
Right.
Or you can choose. Okay, I want to go direction of Quarkus, or direction of Micronaut, stuff like that. So it's going to take more time till we see actually the Spring working natively properly with all the functions. But it's there. You can have it. But it's their time to first request. Sorry. It's not perfect. It's as you can see here, we have this is without native compilation. Okay,
so got it.
The problem is that despite everything, Spring is still lacking some of these things, so support for native stuff. But without even native, these frameworks are great. But it's interesting that even Micronaut was written in that way to avoid reflection. Quarkus is still performing the best in a way that it performs this time to first request is still amazing, the best of all. So and that's the only thing which is important, because many frameworks are faking it. They are loading fast, and they have this lazy loading moment later. So let me go further, and there are many limitations on GraalVM, and I won't go any further. I don't want to spend too much time on this, but yeah, there are limitations, and it's not easy to make something which was dynamic into completely static.
Static, yeah.
So you
So
need
make sure when you're doing this, when you're choosing or when you decide to go the GraalVM or a Micronaut route, make sure that you can do that. Actually, it's not just a matter of
not all dependencies can work in that. So that's a problem. You have to understand, try. So there are a few links. There's also a link to Spring GraalVM native, but as you can see, it's an experimental project. So we'll see. We'll track it.
All these links will be in the description once this video goes up as well.
So just a few seconds. I think I jumped over one slide. Yeah, this is one of the Quarkus slides. So this is where I explain what is the difference of between these frameworks. And you see this REST requests, how much memory in megabytes they take. With this is not about Lambda. This is just running in
general,
yeah. But you can see what's the difference. Like having a native one, 12 megabytes, JVM with OpenJDK 73 megabytes, and then without these optimizations, 136. But the biggest difference is in time to first request.
Response,
first response. Yeah. So this is the biggest issue. So these native stacks tend to spend much more time to run, but later when they're running, they're fine. But the first response is just this.
Wow. That's a massive difference. I mean, I said if you can, definitely go for native libraries if that works in your native binaries. If that works in your environment, as you can get much better performance with this for sure.
Yeah, I would go for that for any, especially REST requests.
Yeah.
Okay, so so at the end, let me do just a quick. So this is fine for you. I mean, you're going to do some Java. Again.
Well, I'm not sure if I'm going to do some Java, but actually, I've made myself a little directory in my repos directory where I will try to make a Java Lambda function. So I will definitely attempt to do it. I'll maybe do it on stream. I don't know. Never written a line of Java.
And if you try this Terraform thing, then you can try this. I mean, this is far easier and better and more useful.
I will test it out for sure.
So yeah, let's spend a few more minutes on something great. I was amazed by this book by John Chapin and Mike Roberts, because this is the book produced by some really experienced guys. And why I liked it is that it really talks about some production stuff.
Okay.
And the way they talk about things is, and the honesty that what they really feel is good, what is bad. That's incredible. So, for example, they were talking almost the same about provision concurrency. Like don't use it. If there's almost no cases for it. If there is a case, okay, but in reality, no. He's talking about Lambda versions in a way that you should avoid using Lambda versions if you have a problem. It's better for you to have for you to be able to make a quick fix and deploy it as soon as possible, because in my experience is that I'm spending too much resources in one stack just to be capable to provide versions and this blue-green stuff when I don't really need them, and I never had any situation where I actually need it. So I was complaining that in one stack I cannot get more than 15 lambdas. That's just if I do everything properly. That's just unnecessary. By removing many of these things, versions, stuff like that, I can get like 24, 30, maybe something. So that's this book has some really great examples of from practice, what should be avoided or not. And there are many chapters in this book, and that I really liked, but chapter 8 and chapter 9 is just perfect. Everything that these super experienced guys know is there. So you just have to read it again and again. So how to the real problems are mostly these problems that you'll learn later. Is that, for example, problem that Lambda, even if you call Lambda once, it can run twice.
Yeah.
More. Yeah.
Yeah, exactly. Yeah.
How do you actually? So first of all, most of the people don't think about that their code can be executed twice, and it's a hard problem. It's not easy. In Java world, we used to use many transactions, especially something called distributed transactions, where we were capable of handling at the same time database and some queue.
Okay.
Then if something happens, we can roll back both things. Just imagine saving something to Dynamo and sending a message to SQS. And if there is some problem in sending a message, you can roll back automatically this thing that you just did in Dynamo. So that's something that is possible in Java, doing if the provider, like if the service provides it, but most of the databases and message queues supported it.
Yeah.
And now all these Java guys are coming into this world where there's no certainty, there's no rollback, there's no transactions, and it's hard to think about that. So you have to make a lot of strategies which are like a low-level strategies. So save somewhere some information, and if I try again, just don't let me do that. But it's not easy to make idempotent systems, so that's hard. So I strongly suggest reading this book. Many of these things that come in this book are not quite in terms of we talked about today, because all these things we're talking now have exploded in the last couple of, let's say, in the last 8-10 months, maybe a year. So it just came after they were working on this book. So I would say that this book is lacking all this cool new stuff, But on the other side, it's if you go through the first chapters, you will understand how to make some of these things by yourself, and like making one project and making multiple builds. It's it's not easy to make one single repo with many lambdas.
Absolutely.
And also they're mentioning stuff which is really important. Like first of the things is this reproducible builds. Sorry, I just clicked. So when you package a function in a zip file, and then deploy it, if it has the same hash like the previous one, it won't take any time to deploy. It will just go.
Exactly. Yeah.
It will not deploy it again. But what happens if I make a native binary? Every time I will produce a different binary. It's it's a bit different.
Yeah.
Just one byte, and that's it. And
you got a different hash every time. Yeah. That's fair.
So if you have like a project with 20 lambdas and you just make change to one lambda, it will redeploy all the lambdas.
Yeah. Definitely.
So we need to address these things. We cannot just dive in so easily. And some of these things are not really easily solvable. Especially when we get into this native stuff, we won't be able to produce reproducible builds. So it won't be
just to answer the question from Michal. Do we have a discount code for this book? I guess we don't.
I mean, this promotion that I do for this book, just because I'm happy, because I like.
Goran didn't write it. Somebody else wrote this book, so Goran is just a big fan of that book. So
I'm just a big fan, And you should also check there was a link. There was a blog from Mike Roberts about influence of different. If you choose different memory or CPU options in Lambdas, how it will affect the speed and stuff like that. So it's interesting that, and we were discussing it a few days ago.
Yeah.
What does it mean, like having 0.9 CPU? It's just an average. It doesn't really matter if you have 1 or 1.1 or 0.9. If you don't have multi-threading, it doesn't really matter.
It doesn't really matter.
So it's and I hope when we get to this ARM CPU age, and when they get Lambdas working on ARM, that we will have maybe a full CPU for every thread that we have. So that's going to be
that would be amazing.
Yeah, that post was great, and I suggest strongly to anyone to read. So sorry guys that we don't have discount code, but you can ask Mike for
check out the book. Check out the book. Goran said a lot of good things about it, so make sure to check it out. I mean, I'm sure.
There are some other books that I really suggest, and this is my reading. This is from if you can see it.
Yeah. Serverless applications with Node.js. So this was written by Slobodan Stojanovic and Alexander Simovic. It's they're both AWS serverless heroes. It's a really great book if you're interested. It's an early book. It came out,
but I really liked it. And the one that just came last year from Goiko, it's also a hero. That's
I mentioned a lot. Yeah.
I like the style of writing, and that's
I mentioned this book a lot, and it's really cool.
But I criticize them a lot because they don't really think about Java, so they're always talking about this
interpreted languages, right?
And then I had a great conversation with Stefano Bugliani that I mentioned in the beginning, who is doing a lot of effort on to get this Spring and all these developers into this world, so they can continue developing in a way they did. If we don't change things, it will be hard to copy paste this old code. If we don't do that, the migration to cloud will take much more time, like years and years. Many applications will work just like we have COBOL applications right now still running somewhere. Even Python is running somewhere or something. So, but
absolutely,
Java definitely. All code in Java will work for many years to come. Many people work.
Like your example, 15-year-old Java code works still. So
that's
a great example. Cool. I guess we are just around the 2-hour mark. Goran, thank you very much. This was a very in-depth look to all of these things. I'm not used to these kind of streams on my end, and I'm sure the audience is not as well. But I'm sure that they appreciate it because they don't get this much depth with me. I learned a lot today. I learned that you can really optimize your Lambda functions by adopting some frameworks such as GraalVM and Quarkus.io, where you can basically compile your applications to either dynamically link but natively compiled binaries without avoiding the Java virtual machines. And thus, improving vastly your cold starts for Java. So on Lambda functions. So I think it's. I learned that you can do that. I've changed my mind about Lambda being serverless.
Did you find interesting this part like of dynamic loading stuff that we all do? We do so much of that thing.
Yeah, absolutely. I think it's very cool. I mean, again, I never use Lambda. I cannot not Lambda. I haven't used Java as much, so I cannot really comment on that too much. But
can you relate that to Python and other?
Yeah, absolutely. I mean,
is a lot of parameters loading and many things.
I mean, On enterprise scale applications, I see this as being great because you can make your application very much optimized. You can be much faster, not just during first execution, but in general, Java runs faster than a lot of things. So if it's written good, and it's not, it's not Java, it's you, right? So make sure to write the code correctly. Cool.
Goran, once again, opportunity, man. I mean, this is.
Thank you very much, and I hope I have you here again. I'm sure we're going to have Goran again here with some other additional Java/Data Hero insights. So stay tuned for that. And to everybody here on stream, thank you very much for joining. And it's been a lovely 2 hours here. Expect the video to be available on YouTube later on. Yeah, all the links we mentioned are going to be somewhere in the description. Feel free to reach out to us both on Twitter, to both me and Goran, for any additional questions. I'm sure Goran would love to answer that. And Goran is also the official AWS Data Hero, so he is very much in the community. Goran, to you, thank you so much for being a part of this. I really did enjoy it. Everybody, thank you very much. We will be ending the broadcast now. Bye-bye.
Bye.
Bye.